Welcome to a lesson with Dr. Powell. Let's take a look at some fractions which are well defined that deal with like zeros or infinities. Now, first of all, we know that division by zero is not well defined, but there is something we can do. And to picture that, think of a y-axis and an x-axis right here. And think about the interval from 1 off to infinity right here, okay, as we go off in this direction. Now this whole interval going off this way, if we would take every number from 1 to infinity and take its reciprocal, where would it land? It would land right here in a finite space. It's like we took something infinite and we squashed it. Why don't we apply an infinite squashing idea to just picture the interval from 1 to infinity as a squash? So we can kind of picture it in here. For instance, the reciprocal of bigger and bigger and bigger numbers gets close. The reciprocals get closer and closer to zero, heading in this way. If we thought about, but none of them will be zero, but then what's the reciprocal of zero? Why don't we just give it a name? Infinity. Sure. Okay. So when we go ahead and we write our axis, we draw our axis now. So let's do that here. We're going to change things up a little bit. We're going to say there's an ultimate endpoint, infinity, kind of after we squash. So we're going to picture this in a finite sense after squashing and just call the endpoint, which would be associated to zero. It would be an open circle, but just think of it as a closed circle. At infinity, negative infinity, positive infinity, negative infinity. If we were to draw a graph on this of like something like y equals 1 over x, usually we have asymptotes, but now we can do something like this because we're after there are infinite squashing. Get something like this with an open circle, open circle. So in particular, we kind of get a function that looks almost as if this is a jump discontinuity or something like that. The question is, okay, let's just write something down. The limit as x approaches 0 from the right side of 1 over x, what would it be? What y value do we need to fill in to make this function right continuous at the point x equals 0 as we're heading in this way? Well, infinity is now on the line up here, okay? So we can use that, and then this looks like this would be right continuous. I mean, like what y value do we need to plug in to make this right continuous at that point, is what I meant to say. Okay, so right continuous to this point, we fill that in, it looks good, right? So that tells us that this limit is actually equal to infinity. Now, this gives us a notion of this 1 over 0 plus. This is another way of writing the limit as x approaches 0 to the right side of 1 over x. It's equivalent. But if we think about this as being defined as a limit or kind of a continuous fill-in plug-in y value plug-in point on this graph after infinite squashing, then we can actually give this a value. 1 over 0 plus is equal to infinity. Notice we didn't write 1 over 0, we wrote 1 over 0 plus. In a like way, we can write 1 over 0 minus. What would that be? That would be equal to, well, it's down here. The y value would be negative infinity. Okay, so we have a specific value that we can assign for 1 over 0 minus. Now, of course, if we're dividing by infinity, that should be clear. 1 over infinity, what's the reciprocal? So if infinity is actually on this line now, what is its reciprocal as we move along? It'll continuously, as we're taking reciprocals of bigger and bigger numbers, they're getting closer and closer to 0. So using the same transferal process, we can think of 1 over the reciprocal of infinity, so 1 over it, as being just 0 itself. And we can do the same thing for negative infinity. So 1 over positive infinity and 1 over negative infinity are both equal to 0. So these are well-defined limit forms, if you will, but if we're thinking on this extended number line with infinities, this works. And you can just think of these guys as numbers here: infinity, negative infinity, 0 plus, 0 minus. These are ideas with limiting. But really what you can do is, if you want to think of 0 plus as a value, you could think of this as being like, okay, we're thinking about 1 over the right continuous version of 1 over x with these infinities, and then you plug in 0. So you plug in 0 to the right continuous version of 1 over x. Here you're plugging in 0 into the left continuous version of 1 over x. So the fractions take a different, so saying 1 over a number has two different forms. There's a right continuous form and a left continuous form at 0. Depending on which form you use, it can actually be well defined. And then you can plug in 0 depending on what form you're using. So this one would be that one would be that. Little description of 0 plus, 0 minus, infinity, negative infinity, and how to divide by them. Thanks for watching.